Let's look at are the following inverse functions, and we need to show our work and explain. So for the first example, we have x plus 10 divided by 8 and 8x minus 10. So I am going to create a table of values to just check to see if they are inverses. So think of some x's that would help to plug in here and simplify easily. So I'm going to pick 6 because I know that 6 plus 10 would be 16, and 16 divided by 8 would be easy to calculate, which would just be 2. Then I'm going to choose, let's say, 14, because 14 plus 10 would be 24. And 24 divided by 8 would give me 3. Then let's pick one more, like negative 2, because negative 2 plus 10 would be 8, and then 8 divided by 8 would give me 1. So I've chosen these values, and they fit with f of x. If these are inverse functions, so this is my table for f of x, then g of x should work if I take these same values, but I trade the x and the y. So I need to trade the 2 and the 6. It's important if you check these with a table of values that you're using the same exact values here to check this one. Like, don't just choose different values or you're not able to see if they are inverses. So now I'm going to plug in the 2. So 8 times 2 minus 10, is that equal to 6? So that'd be 16 minus 10. That does equal 6. And then the next one would be 8 times 3 minus 10. So that's 24 minus 10. That does equal 14. So those both check out so far. And then 8 times 1 minus 10 would give me 8 minus 10 is negative 2. So that also checks out. So I would say yes, f of x and g of x are inverse functions. Because when you switch x and y, it makes sense with the other function. Will be a reason. All right, so let's look at the next example. F of x equals x squared minus 9 and g of x equals x plus 3. So if we were to take f of x, let's do this one a little differently, and we were to try to find the inverse of this. That means we switch x and y, and we solve for y. So if I add 9, I get x plus 9 equals y squared. But now I need to take the square root of both sides to get y by itself, so I end up with plus or minus the square root of x plus 9 is my inverse function. So what you're checking for is if you find the inverse of f of x, is that equal to g of x? So you check over here, and they are not equal. So these cannot be inverse functions. So we would say no, f of x and g of x are not inverses. You could say f to the negative 1 of x is not equal to g of x. So we wouldn't have to go any further in this case, because if that's not true, then they can't be inverses. And you could have also done what we did here with a table of values, would also be a way to show your work. And now let's work on f of x and g of x for this example. So for this one, if we were to create a table of values, let's see. So if we have 5 is our x, that would be 5 minus 5 is 0. And the square root of 0 is 0. And 0 times 2 would just give us 0. Or what if we had, think of something that's easy to calculate. Like, if we want to have the square root of 9, because that's easy to calculate, then let's make x 14. So 14 minus 5 would be 9. The square root of 9 would be 3. 3 times 2 would be 6. So we're just plugging in some numbers that are easy to think about. If we want this to be the square root of 16, we need to make this equal to 21. So 21 minus 5 would be 16. The square root of 16 would be 4. And 4 times 2 would be 8. And you could certainly use your calculator to help you with those. So that's our table for f of x. Let's look at our table for g of x. You need to take the same values you chose for f of x and then switch x and y and see if they would work. So don't choose different values. Use these same pairs of numbers and then plug them into the other function. So I need to plug in x equals 0 for g of x. So 1/4 times 0 squared minus 5 would equal negative 5. So that's not equal to positive 5. Let's check one more and see if that one also doesn't work. So 1/4 times 6 squared minus 5. So 6 squared would be 36. So then 1/4 of 36 is 9, and 9 minus 5 would give us 4. So then that's not equal to 14. So these are not function inverses. Sorry, they are not inverse functions. So we could say, let's just put f of x and g of x are not inverse functions. And another great reason to put is what this tells us is they do not reflect over y equals x. When we substitute the y for the x from one function to another, it does not work out. So that's another great reason we could put there. And now you have 3 examples of how to figure out inverse functions.